here we go. We're in here, and I'm going to come back to our main for the time being, and I am just going to throw this thing straight onto the simulator. And right away, can't be simulated. Do you want to enable support? Oh yeah, we want to enable support. That's fine. It's going to disable everything else. Yeah, that's fine too. And let's see if it compiles. Let's see what mistakes I've got in here that won't even compile. That'll be interesting. So, connection to subnet. All right. Start search. Trying to find our PLC sim. And I hope it shows up. Okay, good. Let's load. And the moment of truth, is it going to compile? Or do I already have something borked? We've got a few more program blocks in here this time, so it's taken a little bit longer to think. Uh-oh, error found. Look at that. Okay, so let's cancel. Let's bring our properties up here a little bit so we can see where we messed up. And scroll down here. Okay, so in our STL, the RLO, the register is not initialized, access invalid. So let's come up here and, okay, so what happened is we're trying to set these values. The problem is we don't have anything to set them to. So yeah, we have to set the register first. So let's go ahead and do that. And we'll just type set. And that will put a true in our register. And I'm going to minimize that simulator so we don't have to look at that anymore. And there we go. Let's try and download now. And good. It looks like that might have been my only mistake. That's not one I can torture myself with for very long. I can live with that. So let's start the module. And okay, I think we've got things running. Let's go online. And yeah, everything's green. All right, so we're starting out, and let's take a look at our program language. We're going to go into monitoring here. And yeah, program language set itself to 1 because when we came here initially, we were out of range. So now we're in range. And if I try to set this something like maybe 222, you see what happens. It instantly goes back to 1. So that's perfect. Now let's try and toggle some of these buttons. So let's just come over here, modify to 1, modify to 0, and now program language is set to 4. And I'll try to set it to 3, modify to 1, modify to 0. Okay, so I'm not going to test those all step by step. It's enough to know that our default is working if we get to a weird value. And if 1 or 2 of our push buttons are working, that's fine by me. So now we can go and actually test our languages. So let's put ourselves back into 1, modify to 1, modify to 0. So now we're set to 1. Coming down here, if we're equal to 1, we should be running our alarm ladder and our I/O ladder. Well, our alarm ladder is empty, so it's our I/O ladder that we're worried about. Let's take our I/O ladder and monitor. And let's see here. To start with, we've got our digital outputs are all energized. And then for our analog inputs, here's where we're trying to scale. And it looks like everything's energized. We don't have to test everything, but I'll go ahead and test maybe one of these. So let's take that percent value and let's set that to something like 60%. And sure enough, we get a value that's within the desired range coming back out. So that's the way we like it. We don't have to test all of these. yeah, basically I'm not going to test any more of these because these are all scaling and they're all working and they're all simple. So let's turn monitor off here and let's go ahead and close this window. And let's test our next paradigm. So we're going to push the button that's going to put us into our second paradigm. So modify to 1, modify back to 0. Now we're in 2. That's function blocks. So let's come in here and I'm going to minimize properties just so we can see a little bit more. Let's monitor. And sure enough, it looks like we're setting all of these guys to true. Come down here and I'll test one of these. So let's test this one this time. I'll set that at 25% and we get the appropriate value out. Good. Whoops. Don't know what I just clicked, but it wasn't my 25. Let's reset that back to 0. And yeah, I don't think we need to test these either. That's all straightforward. So I'll disable monitoring, close this window, and let's test our SCL. So we're going to modify to 1 and back to 0. Now we've got program language set to 3. So let's check our SCL. So let's add a new watch table. And here we go. We're going to look at, we're not going to look at everything, but let's look at whether or not our oil pump VFD is energized. Let's look at our baffle percent and our baffle out. And then let's look at something coming in, like maybe our RPM. So our RPM in and our RPM out, or rather just RPM. And let's throw the monitoring on. So the fact that our oil pump VFD energize is true, that means that our digital outputs are probably all working just fine. And for a baffle percent, let's give it something like 75%. And sure enough, our baffle out gives us a good value. And then for our RPM in, let's say we're getting something like 20,000. And let's send that value in. And it looks like our RPM is not accepting the value. So let's try and send that one more time and make sure that's the only thing we're sending. And look at that. For some reason, our RPM in keeps going to 0, and I know why that is. That's because our simulation logic is doing its job. It's overriding that value, and that's not a problem. So we can go to main, and just temporarily we can go ahead and disable that simulation logic. So I'm just going to put this here, and I'm going to say if false ever becomes true, then run the simulation logic, okay? False should never become true, so that simulation logic should never run. Makes sense, right? Let's go back to our watch table, and now let's send in that value, and sure enough, we're getting an appropriate value back out. Okay, so let's zero everything out. And let's jump into our next paradigm now that we don't have simulation logic in the way. We're going to come down here and set that value to 4. So modify to 1, modify back to 0. We should be in our STL now. And we can pull this up and we can look at monitoring, but oh, actually, look at that. It's giving us some nice values here. Yeah, let's go ahead and work with this. So right away, we can see everything is coming up ones on our digital output, so that's doing what we want. And when we come over here to our values, actually we can set it right in here. That's handy. So let's set ourselves an input signal of 33, and sure enough we get an appropriate value out. I'll set that back to 0, come down here, and let's check an RPM value. So a good RPM value coming in might be 3,000 maybe, let's say. And sure enough, we get a percentage coming out, or actually we get a value coming out that sounds about right. And we can set that back to 0. And okay, it looks like all of our I/O is working. We only had one mistake in the program, and that was I forgot to set a register on my STL. And for testing purposes, I'm going to leave this false normally open contact. I'm going to leave that there for the time being. But anytime we start using our sim logic and we need things to start, moving up and down automatically, we're going to have to come back in and take that out. So just keep that in mind, that that's good for right now, but later on when things aren't working and nothing seems to be changing, that's the whole reason.